There are several potential concerns to consider when placing an air duct near variable frequency drives, also known as VFD. Firstly, heat dissipation is a significant factor. VFD generate heat during operation, and the air duct may obstruct the natural airflow around the VFD. This can potentially lead to overheating and a reduced lifespan for the VFD. Secondly, consider vibration transmission. The air duct could act as a conduit for vibrations from the VFD to the wall and other nearby structures. This could cause nuisance noise or even structural issues over time. Thirdly, maintenance access is important. The air duct would likely make it more difficult to access the VFD for regular maintenance or troubleshooting purposes. Fourthly, it is important to consider code compliance. Local building codes may have specific requirements for clearances around electrical equipment, including VFD. The air duct may violate these requirements, so it's crucial to investigate this. Other considerations are the materials that you use for the pipe of the air duct. The air duct materials should be rated for the temperature and humidity conditions in the area where the VFD are located. For example, if the area is prone to high humidity, a material resistant to corrosion should be selected. Another consideration is the duct supports. The duct must be properly supported to prevent it from sagging or vibrating excessively. Proper support ensures the longevity and stability of the ductwork. The final consideration is a condensate drain. If the air duct is in a location where condensation may occur, a condensate drain should be installed. Condensation can lead to mold growth and other issues, so proper drainage is essential. As a recommendation, consider alternative locations for the air duct that do not obstruct the VFD or compromise their safety or functionality. If the air duct must be installed between the VFD, ensure that adequate clearances are maintained for airflow, vibration isolation, and maintenance access. It is also important to consult with a qualified heating, ventilation, and air conditioning engineer to design and install the air duct properly to minimize any potential issues. This professional can provide expert guidance on materials, placement, and support systems to ensure that the installation is safe, efficient, and compliant with all applicable codes and regulations. Maintaining adequate clearance around electrical equipment such as VFD is crucial for several reasons. Firstly, it allows for sufficient airflow to dissipate heat generated by the equipment during operation. Overheating can lead to reduced performance, premature failure, and even safety hazards. Secondly, adequate clearance provides safe access for maintenance and troubleshooting activities. Technicians need to be able to reach the equipment easily and safely to perform inspections, repairs, and replacements. Thirdly, maintaining proper clearance ensures compliance with electrical codes and standards. These codes are designed to protect people and property from electrical hazards. In addition to clearance, vibration isolation is another important consideration when installing equipment such as VFD. Vibration can be transmitted through the building structure, causing noise and potentially damaging other equipment. Vibration isolation techniques, such as using rubber mounts or flexible connectors, can help to minimize the transmission of vibration and reduce these negative effects. When selecting materials for air ducts and other HVAC components, it's essential to consider the environmental conditions in the area where the equipment is located. Factors such as temperature, humidity, and exposure to chemicals can all affect the performance and longevity of the materials. Choosing materials that are resistant to corrosion, UV radiation, and other environmental factors can help to ensure that the equipment will operate reliably for many years. Proper support of air ducts is also crucial for preventing sagging, vibration, and other issues. Duct support should be designed to withstand the weight of the ductwork and any additional loads, such as snow or ice. The support should also be spaced appropriately to prevent excessive deflection of the ducts. In addition to these considerations, it's also important to ensure that the air duct system is properly sealed to prevent air leaks. Air leaks can reduce the efficiency of the HVAC system and increase energy costs. Sealing the ducts with mastic or tape can help to minimize air leaks and improve system performance. Another important consideration is the placement of condensate drains. Condensate drains should be installed in locations where condensation is likely to occur, such as near cooling coils. The drain should be designed to prevent water from backing up into the air duct system, which can lead to mold growth and other problems. Finally, it's important to consult with a qualified engineer or contractor to ensure that the air duct system is designed and installed properly. A qualified professional can assess the specific needs of the application and recommend the best solutions for ensuring optimal performance, safety, and reliability. When dealing with variable frequency drives, it is important to understand that they are complex electronic devices that require careful attention to detail during installation and maintenance. These devices control the speed of electric motors by varying the frequency and voltage of the power supplied to the motor. This allows for precise control of motor speed and torque, which can result in significant energy savings and improved process control. However, VFD can also generate significant amounts of heat and electromagnetic interference, so it is important to take these factors into account when installing and operating them. Firstly, proper ventilation is essential for dissipating heat generated by the VFD. The VFD should be installed in a well-ventilated area with adequate airflow to prevent overheating. If the VFD is installed in an enclosed space, such as a control panel, it may be necessary to provide additional cooling, such as a fan or air conditioner. Secondly, electromagnetic interference can be a concern with VFD. VFD can generate radio frequency interference that can interfere with other electronic equipment. To minimize electromagnetic interference, VFD should be installed in accordance with the manufacturer's recommendations and should be properly grounded. In addition to these considerations, it is also important to protect VFD from power surges and voltage fluctuations. Power surges can damage the sensitive electronic components inside the VFD, while voltage fluctuations can cause the VFD to malfunction. To protect VFD from power surges and voltage fluctuations, it is recommended to install surge suppressors and voltage regulators. Regular maintenance is also important for ensuring the reliable operation of VFD. Maintenance activities should include inspecting the VFD for signs of damage, cleaning the VFD to remove dust and debris, and testing the VFD to ensure that it is operating properly. It is also important to keep the VFD software up to date, as software updates can often improve performance and reliability. When selecting a VFD, it is important to choose a model that is appropriate for the application. Factors to consider include the motor horsepower, the voltage and current requirements, and the desired level of control. It is also important to choose a VFD from a reputable manufacturer that offers good support and service. Installing an air duct in close proximity to VFD requires careful planning and execution to avoid potential problems. Consider the following guidelines. Firstly, assess the heat generated by the VFD. VFD produce heat as a byproduct of their operation, and this heat needs to be dissipated effectively to prevent overheating. Determine the heat dissipation requirements of the VFD and ensure that the air duct does not obstruct airflow or impede heat dissipation. Secondly, evaluate vibration transmission. VFD can generate vibrations that can be transmitted through the building structure. Assess the potential for vibration transmission from the VFD to the air duct and take steps to minimize vibration. Thirdly, ensure adequate maintenance access. VFD require regular maintenance, and it is essential to ensure that the air duct does not obstruct access to the VFD for maintenance purposes. Provide sufficient clearance around the VFD to allow for safe and easy access for maintenance personnel. Fourthly, comply with building codes. Building codes may have specific requirements for clearances around electrical equipment, including VFD. Consult with a qualified electrical engineer to ensure that the air duct installation complies with all applicable building codes. Other considerations include duct material. Select a duct material that is compatible with the environment in which the VFD are located. The duct material should be resistant to corrosion, moisture, and other environmental factors. Duct support is another important consideration. Ensure that the air duct is properly supported to prevent sagging or damage. The duct support should be designed to withstand the weight of the duct and any additional loads. Condensate drainage is also crucial. If the air duct is located in an area where condensation may occur, provide a condensate drain to remove any accumulated moisture. Another recommendation would be to consult with a qualified HVAC engineer. A qualified HVAC engineer can assess the specific requirements of the installation and recommend the best solutions for ensuring proper ventilation, vibration isolation, and maintenance access. The HVAC engineer can also help to ensure that the air duct installation complies with all applicable building codes. If the air duct is installed in an area where there is a risk of fire, consider using fire-resistant duct materials and installing fire dampers to prevent the spread of fire. Fire dampers are designed to automatically close in the event of a fire, preventing the spread of smoke and flames through the ductwork. Grounding is also critical. Ensure that the VFD and the air duct are properly grounded to prevent electrical hazards. Proper grounding can help to protect personnel from electric shock and prevent damage to equipment. Furthermore, consider noise reduction. VFD can generate noise, and it is important to take steps to minimize noise transmission. Consider using sound-absorbing materials to line the air duct and reduce noise levels. Another recommendation is to perform regular inspections. Inspect the air duct and the VFD regularly to ensure that they are operating properly. Look for signs of damage, corrosion, or other problems. Address any issues promptly to prevent further damage. Consider future expansion. If there is a possibility of future expansion, take this into account when designing the air duct installation. Provide sufficient capacity to accommodate future needs. Before installing an air duct near VFD, conduct a thorough risk assessment to identify potential hazards and develop mitigation strategies. A risk assessment can help to identify potential problems before they occur and allow you to take steps to prevent them. Also, document all aspects of the air duct installation, including the design, materials, and installation procedures. Proper documentation can be helpful for troubleshooting and maintenance purposes. Consider using a building information modeling software to create a virtual model of the air duct installation. Building information modeling software can help you to visualize the installation and identify potential problems before they occur. Training should be provided to all personnel who will be working with the VFD or the air duct system. Training should cover topics such as safety procedures, maintenance procedures, and troubleshooting procedures. Review the air duct installation periodically to ensure that it is still meeting the needs of the application. Make any necessary adjustments to ensure that the system is operating optimally. Variable frequency drives are utilized in a wide variety of applications, from controlling pumps and fans to regulating the speed of conveyor belts and other machinery. They offer a number of advantages over traditional motor control methods, including improved energy efficiency, reduced wear and tear on equipment, and more precise control of motor speed. However, VFD also have some limitations, including the potential for harmonic distortion and electromagnetic interference. Harmonic distortion is a phenomenon that occurs when VFD generate non-sinusoidal currents, which can cause problems with other electrical equipment. Electromagnetic interference is another potential concern with VFD. VFD can generate radio frequency interference that can interfere with other electronic equipment. To minimize harmonic distortion and electromagnetic interference, it is important to install VFD in accordance with the manufacturer's recommendations and to use appropriate filtering techniques. Filtering techniques, such as using line reactors or harmonic filters, can help to reduce harmonic distortion and electromagnetic interference. Another important consideration when using VFD is motor compatibility. Not all motors are compatible with VFD, and it is important to choose a motor that is specifically designed for use with VFD. Motors that are not designed for use with VFD can overheat or suffer other damage. Proper grounding is also essential when using VFD. VFD should be properly grounded to prevent electrical hazards. Proper grounding can help to protect personnel from electric shock and prevent damage to equipment. When troubleshooting VFD, it is important to follow a systematic approach. Start by checking the power supply to the VFD to ensure that it is providing the correct voltage and current. Then check the VFD parameters to ensure that they are set correctly. If the VFD is still not working properly, consult the manufacturer's documentation or contact a qualified technician. Regularly calibrate VFD to ensure that they are operating accurately. Calibration can help to improve the performance of the VFD and prevent errors. Also, consider using a remote monitoring system to monitor the performance of VFD. A remote monitoring system can help you to identify potential problems before they occur and take steps to prevent them. Maintain a comprehensive record of all VFD maintenance and repairs. A comprehensive record can be helpful for troubleshooting and maintenance purposes. When replacing VFD, choose a model that is compatible with the existing motor and the application. Choosing a compatible model can help to ensure that the VFD will operate properly and reliably. Install VFD in a location where they will be protected from moisture, dust, and other contaminants. Exposure to moisture, dust, and other contaminants can damage the VFD and reduce its lifespan.